Okay. There we go. All right. Not this one. I want to do this one. There we go. Hey, how we doing, JTS? Yes, it was. Indeed, it was RimWorld on my desktop. I'm doing very well, my friend. How are you? Me too. The game is very fun. I mean, it's so easy to get lost in that game. All the micromanaging and everything like that. I hope you guys have had a good week so far. It's been an interesting day, I will tell you that much. Still having a few connection issues, so if it kind of cuts in and out, I had an issue with my first two classes. Hopefully I've at least fixed a little bit of it, but again, kind of we'll see where we're at. Hey, Gerda, how are you? I hope you're doing okay. Great. Working on math. Hmm. I see. I mean, that wasn't my plan for the weekend, but okay. You're like math, meh. Okay, that's fair. I'll probably play like Baldur's Gate 3 or something like that. Let me check that fast. What's this email I have? Oh, wow. All right, sure. Roll with that. Hello, Chase. How are you, my friend? College life. College life ain't too bad. Sit back, relax, a little bit. A little bit. Yeah. Easy time, easy life, everybody. Mm-mm-mm. Easy time, easy life. There you go. The Danish Gambit pushed variation. That definitely is a chess thing. Man, if I could go back to my days. Shoot. Here we go. Uh, so that's going to happen. My connection isn't the best at the moment. They did like some repair work the other day. So I don't know what's going on over there. So, all right. Let's go ahead and take a look here at a few things. I think we'll be set to go here in just a second. Uh, all right. Love to do that again. So, all right. All right, let's do this. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today we are going to be moving forward here in Chapter 5, our newest chapter here. So we're going to be doing Chapter 5 here today. We're going to be doing the first section here of Chapter 5. That is what's on the agenda here for today. And then if we get through that, we'll get through a little bit of section 5.4 as well. All right. So let's talk about today in section 5.1 is something that both of you, all of you are familiar with. Both of you, yes. Who's the both? We're going to talk about systems of linear equations. So let's take a look at question 1 here. What is a system of linear equations? All right, let's go ahead and do it out here. So a system of linear equations, again, is basically, let's write it in 16 font here so it's easy to read. So basically that's going to be two equations and two variables. Okay, so we're going to have, say, an x and a y, okay, of some variety. All right. So again, if it does pause or kind of do that a bit, yeah, sorry about that. I don't have control over that. So apologies ahead of time. Okay, so we have two equations and two variables here. Yeah, it's gonna do that. Come on, bro. Do me a solid. Do me a solid. Okay. Sec. Okay. So with two equations, two variables, let's go ahead and check it out and see exactly what we're working with. All right. Okay, so here's an example of two equations and two variables. So I'll just type it out here on my math type thingity thing. So, okay. Oops, I didn't mean to do that. Hello. All right, so here's what two equations, two variables could look like here. You could have like 2x plus 3y is equal to 5, and maybe you have 9x minus 4y is also equal to 5. Okay, so maybe you have something like that, and you're saying, okay, hey, I want to solve for both x and y here in this particular circumstance. All right, this can be, we're going to work with that here and then, solve for both x and y. All right, now, what's the key here into doing these type of problems? Okay, so this is just an example problem. This is not a problem we're actually going to be doing. But what's going to be some methods here in order to solve for systems that look like this? Well, the first one here is the first way we're going to solve it for is going to be within question number 2. So question 2 says, how do we solve a system by substitution? Okay, so we're going to talk about the steps of how to do substitution, and we're going to see exactly how to met that out. All right, so let's put up a problem here right away, and then we'll go ahead and see what we're working with. All right, so let's go ahead and pick one here that doesn't absolutely stink. So there are a lot of problems that do. Actually, I think that one's a bit better. I don't like problems that are just too easy either. I want to pick one that's pretty good. Okay, so here we got 2x plus 5y is equal to minus 4, and 3x minus y is equal to 11. All right, so let's go ahead and see here how we can solve for x and y here appropriately. Okay, all right. So I'll just post it here. Okay, so we'll reference back to this problem here so you'll know what we're doing. Alrighty, now let's talk about step number 1. All right, so step 1. Step 1 is you're going to choose one of the two equations and solve for a variable. Okay, so you're going to choose one of the two equations. You're going to solve for one of those letters, whether it be x or y. Doesn't really matter. It's like, okay, you get to make that choice. Okay, at the end of the day, obviously you want to pick the easiest of the easies. Okay, so that's what you're kind of after here in a problem like this. Okay, so taking a look at this here, what would be the easiest equation to use, and which variable should we solve for here? What do you think would be a good idea? Should we solve for x or should we solve for y? And which equation should we use? Should we use the first equation or the second equation? All right, y, and y in the second equation. Okay, I agree. So let's, I'll write step 1 over here. So we're going to use 3x minus y equals 11. Now, the question people ask is, how do I know that it's going to be y in the second equation? Well, you try and pick the variable that maybe it's just sitting by itself, which makes it a little bit easier to solve for. You may not always have that option in every problem, but in this particular case, again, it's actually not as bad as it may seem. So we have 3x minus y is equal to 11. Sorry, that's covered by my face. So we'll go ahead and solve for y here in this instance. All right, so we're going to go ahead and subtract by 3x on both sides. All right, so we'll have minus y is equal to 11 minus 3x. All right, what do we do? What do we do next? How are we going to solve for y here? All right, divide by -1. And where do I divide by -1 on the right-hand side? Where do I divide by -1 on the right-hand side here? Do I divide it just by the 11? Just by the -3? Both. Okay, very good. That's right. Okay, so it has to be for both. All right, every term. Now again, you just need, the reason why I stress this is just because it's a lot easier to see if signs change when you divide by, say, a negative number, if you divide each term by that same number. So this is a good example of that problem. So 11 divided by -1 is -11. But as you can see here, we get -3 divided by -1. Okay, so in fact, this will be plus 3x. All right, so again, be careful about signs here. That's very important. Okay. Always the biggest mistake in these problems is just signs. So, yeah. All right, so that's step 1. All right, let's move on to step number 2, and let's see how we can work with that. All right, step 2. Okay, so step 2 is to use, okay, I remember you have connection issues there, Gerda, so I totally understand. You've mentioned that before in the past. So, it's okay, Gerda. You could watch the replay here on Twitch. Okay. Yeah, so don't worry. I always have replays of everything, okay? So that way you'll get back there. I totally understand. All right. So what we're going to do is we're going to use the result of step number 1 and substitute it into the equation we did not use in the previous step. Okay. All right. So what are we going to do here in this case? All right. Here in step 2. Now we're going to do the actual substitution. So let's bring back our guy right here. Okay, now we do have two equations here. We did use 3x minus y is equal to 11. We definitely did that. But we did not use the first equation here of 2x plus 5y equals minus 4. All right, so that's going to be, I'm going to put this down here. Now, since we went ahead and solved for y in this first equation here, I'm going to underline minus 11 plus 3x. We're going to substitute that in for y in that second equation. So I'm going to just draw an arrow so I know exactly where I'm going to be substituting once I have that set and done. So what I'll have here is, if I substitute here for step number 2, specifically, it will be 2x plus 5 times the quantity negative 11 plus 3x equals negative 4. Okay. All right. So that is basically step 2. I'm putting that as a separate step here because, you know, just making sure we get the correct substitution down during the process. Okay, let's talk about step 3. Step 3 is to solve for the remaining variable. So you're just solving for that remaining variable that you see. All right, so what you have here is you have 2x plus 5 times the quantity negative 11 plus 3x equals negative 4. So again, we just want to solve for x since that's the remaining variable that's left over after everything is said and done. So we'll go ahead and figure that out right now. So we'll put this up here. So we're going to have 2x, and we'll distribute the 5 here to both of these. So we'll have minus 55 plus 15x equals minus 4. Okay, so we're going to get 17x minus 55 equals minus 4. All right, add 55 to both sides. All right, this is pretty easy after this, so shouldn't require too much effort. 17x equals 51 divided by 17. All right, so x here is equal to 3. Okay, so we got x is equal to 3 here as our answer for 51 divided by 17. Okay, so we found one of our answers here. Awesome. Now, let's go ahead and do step number 4, which is the easiest last step, is, okay, use the result of step 3 and step 1 and step 1. So I guess just say results with an S. All right, to solve for the other variable. Okay, so that's all you want to do here is you want to solve for the other variable here using the results of both the previous step and the first one here. Now, what do I mean by that here? Well, in this particular case, if you remember back here in step number 1, we found that y is equal to negative 11 plus 3x. So we know that x here is specifically equal to 3. So we can plug in 3 into what we had solved for y here in this first step. So we have negative 11 plus 3 times 3. So this is negative 11 plus 9. So we get y here is equal to minus 2. And that's going to be our final answer for this problem, is we're going to have the answer here of 3 comma minus 2. You'll notice that on the homework there, they'll probably ask for ordered pairs or have x is equal to some number, y is equal to some number. So that is going to be our answer for this problem. All right. Are there any questions about that example? So hopefully that made a whole lot more sense. Okay. All right. So let's go ahead and take a look here at another example. All right. So this time I'll have you guys guide me through this example. All right. So let's take a look at this next one. All right. Let's pick the next one here. All right. That's a good one there. That's very advanced. Well, stick around and find out, and hopefully it won't be as advanced. Just, one thing about math is just basically to take it slow. So if you take it one step at a time, as opposed to trying to go a million miles an hour, it makes it a lot easier on your brain. So it worked for me, I could tell you that. I used to be terrible. So when I just slowed down and things like that, I got a lot better. I got a lot better. Just, one foot in front of the other. Things may be advanced, but it's possible to learn it. So this is for college algebra, actually. If I can spell algebra, I'll let you know. There we go. All right. Doesn't matter what. Doesn't matter where you're from to me. If you're willing to learn, you're always welcome here. There are no judgments in this class. It's just a matter of, hey, if you're willing to want to learn, I'll be happy to show you. Okay, you're studying equations and maintenance. Okay, you're 1 year away of finishing high school. Wonderful. That's great. I'm not sure. Maybe I'm confused. I'm not sure how that was. Uh, hmm. Maybe. Hmm. Sorry about the delay there. Yeah, let's not get into semantics here. I understand. Relax, everybody. It's fine. This is a learning atmosphere. All right. I respect anybody and everybody who comes into this space. Like I said, if you want to learn, I'm cool with that. So, you know, I'm here to help as much as I possibly can. Let's focus on what we got in front of us, though. All right. And let's see what we got here. So, all right. Okay. Now, let's take a good look here at this first one. We have, we're going to go ahead and solve for x, right, in the first one. Good. All right. So we're going to solve for x in equation 2. All right. So you have 6y minus 8, pardon me, equals x. That is correct. Okay, good. So let's go ahead and show that off here at the very least about how that happens. Again, we're going to subtract by 6y on both sides. And so we have negative x here is equal to 8 minus 6y. All right. And then we're just going to divide by negative 1 everywhere. All right, so here we get x is equal to negative 8 plus 6y. Okay, yes, so that's correct. 6y minus 8 or negative 8 plus 6y. They're both the same thing. So there we go. Got the first part there of step number 1. All right, perfect. Okay. All right, now what's step number 2? What are we going to do next? What's step 2? What are we going to do next? All right, so if you did the substitution there, all right, if we did the substitution there, what does that look like? Yes, I agree. Everybody's got the right idea. Now I just want to know what that looks like. Okay, great. So let's go ahead and do that here. So what we're going to do is we're going to go ahead and put negative 8 plus 6y. We're going to underline that. And since we solved that for x in the second equation, I'm going to go ahead and just draw our arrow. Again, if it helps, just draw your arrow to the first equation we didn't use. We didn't use equation 1. So we're going to place it into that x right there. So again, this is like equation 1. This is equation 2. So JTS, that's correct. Okay, so we're going to have 2 times minus 8. You're just missing the y, but I know what you meant. Plus 6y. All right, plus 5y equals 1. Okay, So we have exactly that. Perfect. Nice. All right, so that shouldn't be too bad. Okay, let's move to step number 3 now that we have that. Okay, so let's go ahead and distribute here. We're going to solve for y here, so we're going to distribute this 2 to both of those terms. Okay, so we're going to have negative 16 plus 12y plus 5y equals 1. Okay, I'm pretty sure you guys have probably already figured out what this is going to equal. So, let's go through the motions here at the very least. So we add 16 to both sides here. So we get 17y is equal to 17. Then divide by 17 on both sides. So 17 divided by 17 is 1. Okay, exactly. Nice. Okay, so far so good. Okay, any questions about how we solved for y there in that equation? No? Okay. Want to be sure that at least we're clear about how we got to y, as that is the toughest part in the process. Okay. Well, let's go to the last part here. Let's go to the last part here, which is the last step, all right, for y here. Okay, so what we'll have here specifically is we're going to go ahead and put in y is equal to 1. Again, you can use this equation that we underlined here. So we have, again, x is equal to negative 8 plus 6y, and we'll replace with the y with y equaling 1. So x here is equal to negative 8 plus 6 times 1. So that's going to be negative 8 plus 6. And so here we get minus 2. So here we got our answer of minus 2, comma 1 as our ordered pair. And that would be our final answer. Okay, any questions about that? No? Yes. So if you tried any one of the two equations, you'll still get minus 2. It doesn't matter which equation that you actually use. So yes, you have a lot of flexibility once you solve that y is equal to 1, and you'll still find the same answer regardless of what you do for x. Okay. So that's what's nice about these problems is that you could just go ahead and just plug it in, you'll get it either way. All right, so that is the substitution method. All right, fair enough. Let's move on here to the next method. All right, how do we solve a system by elimination? Okay, now elimination, on the other hand, this is also called, this is This is pretty much AKA the addition method. So you'll see that possibly written in the homework there. You'll see it say, hey, can you do the addition method for this system of equations or whatever? And then you're like, okay. There you go. Why don't they teach children calculus first? You need a lot of basis to learn calculus right away. So you need some trigonometry, some pre-calc stuff, some more algebra. You gotta work like in a loop. Gotta come back around. The real question you should ask yourself is that if you took high school and whatnot, the real question you should ask yourself is, why didn't they challenge you more when you were going to school? Why did they water it down? That's the real question. All right. Okay, let's go to step number 1 here as part of our elimination process. So, step 1, we're going to choose a variable to eliminate. Okay? So that's going to be step 1. We're just going to choose either x or y, and we're going to make darn well sure that we get rid of that variable. All right, that is going to be step 1. Let's go ahead and put up a problem here and at least showcase that along with our steps here. Okay. So let's go ahead and put this into effect here. Which one am I going to do? Okay, let's do that one. No. Okay, that's fine. All right. So I'm going to put 3x minus 7y equals 13. And we're going to have 6x plus 5. All right. Should be a 5 here. Okay. All right, so 3x minus 7y equals 13, and 6x plus 5y is equal to 7. All right, so we are not going to go ahead and, again, substitute here. We're going to do elimination, which in our case is going to be much easier than that of much easier than doing the substitution method here. All right, let me let's go to step 1 here. Now, I'm going to have you guys choose here. All right, so you guys make the choice for me. Which variable would you like to eliminate? Would you like to eliminate x, or would you like to eliminate y? Y? Okay. Let's go ahead and eliminate y. And that's fine. All right. So we're going to choose to eliminate y. All right. Fine. Y it is. Now, let's talk about once we choose to eliminate. Why is the choice to eliminate very important? Well, if once we choose a variable to eliminate, what we want to do is we want to do one very important thing in step 2, and this is the big crux of the whole, this whole method, is that we're going to multiply. All right, so we're going to multiply here one or both equations by numbers so that the coefficients of the eliminated variable are opposites of each other. Okay, now you're probably saying, whoa, time out. Let me zoom out of this here. You're probably saying, whoa, time out. What does that mean? You know, what's going on with that? All right, so, and that's fair. All right, that's very fair to say. So I want you to take a look here at y. We want to eliminate y. That's the whole point of the whole process, is to get rid of y. Okay, so if we want to eliminate y, let's take a look at what we have right now for the y's. We have minus 7y here in the first equation, and we have 5y here in the second equation. Okay, so we want to make sure that this number here in front of y is opposite of that number here in front of y. Now, minus 7 and 5 have maybe a number in common that we can actually get to, where one of them can be minus and one of them can be plus. So 7 and 5 only have one number in common, and that's 35. So I'm going to multiply this by positive 5, and I'm going to multiply this by 7. Okay? Now, if you take a look here carefully, okay, I'm just going ahead and I'm going to multiply everything in here by 5, and I'll multiply everything in here by 7. Okay, so what I'll have is I'm going to have 15x minus 35y equals 65. Again, I am multiplying this 5 by the answer. Don't forget about that. Okay, that's very important here. Then I'll have 42x plus 35y equals 49. Okay. All right, so that's what we've in effect went ahead and did, is I multiplied by 5 to get minus 35, and I multiplied by 7 to get plus 35. So these are now opposites of each other, like the step 2 has basically said here. It wouldn't be minus 7? No. The reason why it would not be minus 7 is because of the fact that here, in this particular instance, then I would get minus 35 down here. I don't want minus 35 and minus 35. Remember, I want to be sure that they are opposites of each other. That's the important part here. All right? I need to be sure that they're opposites. So I need one of them to be positive, one of them to be a positive number. I need the other one to be a negative. All right? Never the same sign. So I have minus 35 for the y's on top. I have plus 35 on the y's on the bottom there. Okay? That's why I chose not to use minus 7. Okay, any other questions before I move on? Nope. Okay. All right. All right, next, let's go to step 3. Step 3. Let's do it. All right. Step number 3. Step 3 is basically what we're going to do next is we're going to add straight down. Okay, so we're going to add straight down. That's what we're going to do. All right, so we call this the addition method because we are adding these two equations now straight down. All right, and this will lead us into the last couple steps here for sure. All right, so if we add straight down here, then 30 minus 35y and 35y are gone. Okay, those are eliminated. Okay, so you add straight down, and I'm going to add a little bit to this and solve for the remaining variable. Last step here is basically step 4. Use any one of the two original equations and the result of step 3 to find the other variable. Okay, all right. Okay, so let's show off exactly what this is going to look like. So we have 15 plus 42, that's 57x. The y's have been effectively wiped out, so they're gone. And here we're left with 114, okay? So that's what we have there. Then we just go ahead and solve, all right, like we normally do. So let's go ahead and do that. Divide by 57 on both sides. Okay, so here we get x is equal to 2, all right? So we get x is equal to 2. And then we just can use any one of the first two original equations, and we could just plug in the value that we just got here for x, okay? So here we get, let's choose the first one, choose the second one actually as an example. So we have 6 times 2 plus 5 times y equals 7. This would be step 4. So we get 12 plus 5y equals 7. Subtract 12. Running out of space. Let's see if I got just a tad bit more. Oh, sorry about the spacing thing, but 5y here is equal to minus 5. Divide by 5. So y here is equal to minus 1. So we have our two answers here. X is 2, y is minus 1. Okay, and there we go. We got our answer for this problem. All right, any questions about that? Yes. All right, cool. All right, cool beans. Okay, so let's go ahead and try another example, and let's see if you guys can guide me through it, all right? All right. Let's do another problem here. Let's see which one I want to do. Sure, let's do that. Okay, so here's our equation here. We have 2x plus 3y equals minus 16, 5x minus 10y equals 30. Okay, So let's go ahead and see if we can solve for x and y here appropriately. All right, so let's go ahead and choose a variable to eliminate. All right, you guys tell me, what variable should I eliminate here? You guys can choose. Okay. JTS says y. I said, okay, that's cool, bro. All right, so we're going to choose y to eliminate. Okay. So we have a 3 and we have a -10. That's what we got so far. So what are we going to multiply by to eliminate y? What are we going to do? What should we multiply by to eliminate the y's? And we get those opposites of each other. How about this, okay. Okay, so you multiplied the first one by 10. That's perfectly fine. All right, totally agree with that. How about the second one then? 3. All right, perfect. That's right, nice. All right, this will ensure us. Yep. So yeah, I know what you meant there. It's all good, buddy. So this will ensure we get positive 30 and we get minus 30. So let's take a look at what happens here. Get 20x plus 30y equals minus 160. And here we get 15x minus 30y equals 90. All right. So far, so good. Sounds like a plan. All right. Now all we need to do is simply solve for x. So what do we get for x here? We get 35x here, by the way. So does anybody got an answer for x? Add straight down? Absolutely. 100%. So who's got an answer for x here? -2. Very nice. That's right. All right, so x is equal to -2. Perfect. Okay, so we have one answer here. Good to go there. Okay, let's solve for y. So let's use whichever equation. It doesn't matter which equation you use. You'll still end up with the same answer. So we'll use the first one since it looks easier. So 2 times -2 plus 3y equals -16. So I get -4 plus 3y equals -16. So you get 3y equals -12. Divide by 3. Y is equal to -4. All right. Okay, and that's going to be our answer, -2 and -4. Perfect. Any questions about that? Remember, if there's one important thing in math, indeed. All right, next. Let's go ahead and do the next problem here. Now, the next problem here, I'm going to go ahead and do out, and I'll show out how this works. So this one here will go really fast, but it is an important problem nonetheless. So, which way I want to do that? Yeah, I think I'll do it that way. Okay, next example. Okay, so let's say we're given this particular system of equations. And then we just said, okay, you know what? We're going to go ahead and solve for x and y. Well, you do elimination, okay? We'll do the addition method. We'll go ahead and get that done. Really not too much of a problem. Now, the way to do this is we're just going to go ahead and multiply this first equation by -3, as we're going to choose x to eliminate. So I'm going to have, excuse me, -6x minus 15y equals -30. Okay, so basically, again, I chose x to eliminate. And then on the bottom here, I have 6x plus 15y equals 30. All right, now let's talk about what we can see here. What we can see here is that we have -6x plus 6x. All right, now the x's get eliminated, and that's exactly what you want to have happen since we chose that at the beginning. However, for the y's, what we're going to do here specifically is I'm going to not write, my -15y plus 15y here, I'm not going to write just 0. I'm going to write 0y, just to illustrate what will happen next. And 0y here is going to equal -30 plus 30, which is also 0. Okay. So the question is, in this case, what's the answer for y? What's the answer here in this instance? What's the answer going to be here if we run into this situation? No solution? Okay. That's one possibility. Anybody else? What do you think? You look at this and you're like, 0y is equal to 0. All real numbers? Okay. So I got two answers here. I got no solution and all real numbers. Now I agree, one of those is correct. Which one would be correct? Let's think of it this way. Undefined, not undefined. Can't divide by 0, right? So I don't think that's a thing. Let's think of through this a little bit logically here, okay? Here you can see we have 0y is equal to 0, right? Well, 0, let's say we put in any number here, was 0 times what number is equal to 0? Let's think of it that way. 0 times what number is equal to 0? 0 times what number is equal to 0? All the numbers, any number, that's right. That's correct. Remember, it's not just 0, it's all numbers, right? Because again, 0 times whatever number you want it to be, doesn't really matter, it could be a billion for all we care, is always going to equal 0. So in this case, if you run into this situation doing a system of equations, this is going to reflect infinite solutions. Okay? So this is a case where we get infinite solutions. Now, the first one was recommended by JTS. You'd be like, okay, hey, what if it's, no solution? Is there a way we get no solutions here? Well, there is a way we can get no solutions. If I made one change to this problem, I'll just show you what happens if I make one change to this problem, that I could get no solution just as easy as I could get infinite solutions. So let's say I change this 10, let's say I change that to a 9. And let's say this became minus 27 instead. Okay. So in fact, what I would have here in this diverted problem is I would have 0y. Everything's the same. All the steps are the same. The only thing is that I'd have 0y is equal to 3. And in this case here, just like we justified the part before where we said 0 times anything is 0, well, 0 times anything can never equal a number that's not 0. It can never equal 3. There's no number in the universe where that's going to happen. So in this case, if you get a non-zero number here, it could be any number, this would indicate no solution. You may also see no solution written like this on the homework. So you may see like a big circle with a line through it. So if you do see that, that's also another representation of no solution as well. Okay, so those are the kind of subtle differences between both no solution and all solutions. All right. Any questions about that? Nope, nope, nope. Okay. Could be better explained? Youch. So mean. Couldn't? Ah, you can't take that back anymore. You're too late, Chase. You're too late. I did test a theory the other day. This was a very important thing that I had to check for myself. Absolutely. Impossible. Yeah. Totally, totally impossible. Uh, it's whoop, that was my friend. Asians don't really have enzymes to process milk appropriately. Most of us are actually lactose intolerant to some degree. I love milk. Mind you, I love my cheese, okay? I just know that you don't have being Asian, you don't have the enzymes to properly process it completely. So 99% of Asians don't have that enzyme to process it completely properly. All right. Yeah, we got to do this next one here. Eventually, I'm going to get around to doing this. Eventually, yeah, things. All right. All right. Let's go ahead and move forward here with these questions. Number 4 and 5 here on the handout. So let's go ahead and do that. All right. All right. Okay, let's take a look here and number 4. Number 4 says, what are profit, cost, and revenue functions? Okay, so let's discuss what each of these are here. I'm going to start off with cost, and then we'll go with revenue, and then we'll go with uh, profit functions here. So cost here basically is going to be the way we think about business, and we think about, cost. How much does it cost for us to run this business? So basically, it'll look like this. It'll be the cost for the cost to produce the item times X, which is the number of items that you produce, plus a fixed cost. Now, just to clarify what the fixed cost is going to be, the fixed cost is like buying all the equipment to make said item. Okay, so if you say, hey, I'm running a pizza shop, I need to buy the equipment for said items like, the ovens and the pans and, all the tables and chairs if you have a restaurant or something like that. Well, those are fixed costs that you have to factor in. So up front. Before you even make one pizza, you got to get everything else behind it, for example. Okay. Um, next is revenue. Revenue is basically going to be the price of the item times X, which is how many of the items that you sold. Okay. So that is going to be revenue. All right. Yep, that's true. And profit here, what is profit? Profit is going to be the revenue minus the cost. Okay, so revenue minus cost here is going to be the profit function that we can go ahead and put together. Okay. Now, in relation to this, that also answers number 5. Number 5 says, what does break even mean? Break even essentially means is where revenue, let me put that slightly bigger here. It basically says where revenue is equal to cost. Okay, so when we start breaking even is basically when we start making profit. So of course it costs us some money to make the first number of units, and then beyond that we're now increasing our profit margin the more units that we sell after a certain point. Okay, now let's go ahead and do an example of this, and we'll see how this works out. All right, good stuff. All right, so I'm gonna write out a problem here. This one here will be a word problem. Let's go with that. A company manufactures small canoes, has a fixed cost of $18,000. Okay, it costs $20 to produce each canoe. The selling price is $80 per canoe. Okay, now we're gonna find 3 things here. We're gonna find 4 things, I should say. I should mention out. Okay, letter A. We're gonna state the cost function, C of X. State the revenue function, R of X. State the profit function, P of X. And then finally, find the break-even point. Okay, so we're just doing these 4 parts here for this example. Most of them are not very hard. They're very short. It's just a matter of just putting it together. That's all. Okay, let's look at the first part here. State the cost function. So we're going to have a cost function here. We'll call it C of X. Okay, now, can anybody tell me, based on the word problem here, what would be the cost function here of this particular word problem? What would be the cost function here in this word problem? Just 18,000? Well, let's take a look here. Again, our cost function here. Again, don't forget what that's equal to. Okay, that's correct. So it's going to be 20x plus 18,000. That's correct. Okay. So 20x plus 18,000 is what we have here. All right. So $20 to make each canoe plus the $18,000 of fixed cost, which is like, say, the equipment cost here to make that. All right. How about the revenue function? What's that going to be? $80x. Okay, good. That's right. We sell it for $80 a canoe. So therefore it will be 80x. That's right. All right. Now we want the profit function here. So let's do the profit function here. Now remember, the profit function here is the revenue function minus the cost function. Okay. Now, one of the things that I want to point out here about this part, and why I'm not kind of asking you for this one here, is because you have to be a little bit extra careful about the minus sign in the middle. Now, we indeed are taking the 80x from, we're indeed taking the 80x from the revenue here. However, that's going to be minus 80x minus, oh, why did I put blanks there? We're going to have 80x minus the quantity of 20x plus 18,000. So what that means is that you need to distribute the minus sign to both the 20x and the 18,000. So that's going to be our note here. Note. That's going to be very important in this part of the problem, okay? So again, that's the most common mistake I see on this particular problem, writing out a profit function. It's exactly that part right there. So we actually have 80x minus 20x minus 18,000, which is going to equal 60x minus 18,000, okay, if we want to write out our profit function. Okay. Any questions about that before we move on to the last part? Okay. All right, let's do the break-even point then. Now for the break-even point, we're going to set the revenue equal to the cost. So we're going to set, again, R of x is going to equal C of x, okay? Go ahead and put a little space in between there. There we go. Looks a lot nicer. Okay. So we're going to have 80x is equal to 20x plus 18,000. All we're going to do is subtract 20x on both sides. And then we're going to get 60x equals 18,000. Divide by 60 on both sides. So here we get our final answer. How many canoes did they have to sell before they start turning a profit? The answer is 300. Okay, so 300 canoes to start breaking even and start painting in the black. Any questions about that about that problem? Nope. Any questions about section 5.1? That is the end of section 5.1. Yeah. Nope. All right. All right. No questions? All right. No problem. Okay. Very good. All right. So that'll take care of it for today, everybody. I want to thank everybody. That's no. Apparently you don't like that. All right. Let's go back. Guess I didn't like that. All right. That's fine. Yes. Thank you. I'm gonna. Okay. All right. All right. I want to thank everybody very much for coming out here today to the stream. Again, sorry for the buffering issues. Not sure what's going on, but I think it's just because they did repairs on my connection. So on the whole neighborhood, but have had some technical difficulties lately. So hopefully that'll get fixed out. Again, I want to thank you all very much for coming out here today. Again, there is a test to do, so don't forget to finish that on time. All right, so be sure to hop on to Alex and take care of that. I'm not going to do the second section here today. It is stuff to do with substitution elimination, but yeah, I'll just let you guys go early here today so you guys have a chance to relax a little bit more for the weekend and not have to cram your heads full of information. So thanks everybody again. You guys are the best. You guys are great. All right. Everybody have a very wonderful weekend. Stay safe, stay healthy, and stay sane during this time. All right? I'm there with you. All right? Have a great night everybody, and we'll see you later. All right, everybody. Take care. All right. Bye.